Hi guys, in today's lesson, I'll be teaching us an important topic in chemistry named stoichiometry. And I know you guys don't want to miss this. So if this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So let's commence with today's lesson. Now, what is stoichiometry? Please take note that stoichiometry is the art of measuring chemical elements in quantitative analysis or relationship in chemical reaction. So please take note that stoichiometry is what? Is the art of measuring chemical elements in quantitative analysis or relationship in a chemical reaction. So please take note of that. Now please take note that the word stoichiometry, please take note that the word stoichiometry, the word stoichiometry can be divided into two. The first part is stoichio, while the other part is this metry. So please take note that the word stoichiometry can be divided into two. The first part is stoichio, while the other part is metry. Now this stoichio means what? Please take note that this stoichio means element. So please take note that the stoichio means what? Element, while the metry means measurement. So the word stoichiometry can be divided into two. The first part is stoichio, while the other part is what? Metry. Now the stoichio means what? Element, while the metry means what? Measurement. Now when you combine the two of them together, you get the full word stoichiometry. That's the reason why when you are defining stoichiometry, you define it as the art of measuring, you can see it here, measuring what? Chemical elements in what? In quantitative analysis or relationship in what? In a chemical reaction. So please take note of this I've just brought out right now. So please take note that in order to solve stoichiometric calculations, you must be able to balance chemical equations. If you cannot balance chemical equations, there's no way will be able to attempt stoichiometric calculations. And I've taught about these chemical equations, balancing of chemical equations, which is on my YouTube channel. I want you guys to watch that video if you have not watched it before. Watch that video on balancing of chemical equation, so that you know how to balance chemical equations. So from here, we'll be moving straight away to mole concept. There's no way you talk about stoichiometry and not talk about mole concept. In fact, mole concept is the basis of stoichiometry. So we'll be talking about what? Mole concepts. And under mole concept, mole concept. So we'll be talking about what? Mole concept. Now, under mole concept, we're talking about what? A mole. Now, what's a mole? Please take note that a mole is the amount of a substance that contains what? 6.02 times 10 raised by 23 particle. So please take note that a mole is the amount of a substance that contains what? That contains 6.02 times 10 raised by what? 20 times 10 raised by what? Power 23 what? Particle. So please take note of this, that a mole is what? A mole is the amount of what? Of a substance that contains what? That contains 6.02 times 10 raised by 23 particle. Now, this 6.02 times 10 raised by 23 particle is what? Is known as what? As Avogadro's constant. So please take note that this 6.02 times 10 raised by 23 particle is known as what? Avogadro's constant. Please take note that this 6.02 times 10 raised by 23 particle is known as what? As Avogadro's constant or Avogadro's number. So please take note that it is known as what? Avogadro's constant. Avogadro's constant or Avogadro's number. So please take note that this 6.02 times 10 raised by 23 particle is known as what? Avogadro's constant or what? Avogadro's number. So should please take note of what? Of this under what? Under mole concept. And earlier on I said that a mole is the amount of what? Of a substance that contains what 6.02 times 10 raised to the power 23 what particles, and I said that this value is known as what Avogadro's constant or Avogadro's number. So we should please take note of what? Take note of this. So from here, we'll be talking about what? Mole relationship under what? Under mole concept. So under mole concept, we're talking about what? Mole relationship. Now, the first relationship that we're talking about here is what? Is mole and mass relationship. So this will be the first one that we're talking about, mole and mass relationship. Now, under mole and mass relationship, please take note that mole is equals to what? Mass over what? Molar mass. So please, under mole and mass relationship, please take note that mole is equal to what? Mass over molar mass. Here the mole is the what? Is the mole. Now the unit of mole, okay, the unit of moles is equal to what? Mole. So please take note of this. While the unit of mass is what? Gram or kilogram. So please take note of what? Of this, of their SI unit. Whereby the unit of what? Of molar mass, the unit of what? Of molar mass is equal to what? Gram per mole. You can write it like this, gram per mole, or gram per mole raised to the power what? -1. So you can either write it like this or like this. So please take note of this. So the first relationship that we're talking about under relationship, under mole relationship is what? Mole and mass relationship. Under the mole and mass relationship, we have what? Moles equals to what? Mass over molar mass. In some cases, you can refer to it as number of moles. Number of moles or moles is the same thing. So moles equals to what? Mass over what? Molar mass. Where the moles, the unit of this moles is what? Is mole. While the unit of mass is gram or kilogram. But in chemistry, it's majorly most times in gram. While the unit of molar mass is what? Gram per mole. Is that you write it like this? Gram per mole or what? Gram per mole. So whichever one is correct. So under mole and mass relationship, please take note of what? Of this formula. It's very essential under stoichiometry. Now we'll be moving straight away to the next relationship, which happens to be what? Mole and particle relationship. So this is the second relationship that I'm talking about, mole and particle relationship. Now under mole and particle relationship, we have mole equal to number of particle over 6.02 times 10 raised to the power 23. So under mole and particle relationship, we have mole equal to what? Number of particle divided by what? 6.02 times 10 raised to the power 23. And of course, I said the name of this earlier on when I was teaching. Please take note that 6.02 times 10 raised to the power 23 is known as what? As Avogadro's constant or Avogadro's number. So under mole and particle relationship, we have mole equal to what? Number of particle divided by what? 6.02 times 10 raised to the power what? 23. So please take note of all these relationships and all these formulas that I'm bringing out right now. This really helps under stoichiometry when you're calculating stoichiometry calculations. So please familiarize yourself with what? With all these equations that I'm bringing out right now under all these relationships. Now, the last relationship that we're talking about is what? Is mole and molar volume relationship. Now, under mole and molar volume relationship, we have mole equal to what? Volume at STP, divided by what? By molar volume. Now this molar volume, it has what? A value, and the value is 22.4 dm cube. Now in dm cube, the value is what? 22.4. But in cm cube, it can also be what? In cm cube. But in cm cube, it is what? 22,400 cm cube. So please take note of what? take note of this. So under what mole and molar volume relationship, we have mole equal to, like I said earlier on, you can call it mole or what number of mole, whichever one you want to use is still correct. So mole equal to what volume at STP divided by what molar volume, and I said that this molar volume has what a value which happens to be what 22.4 dm cube. Now in dm cube it is what 22.4, while in cm cube, because it can also be cm cube. Now if you multiply this 22.4 with 1000, which happens to be 22.4 times 1000, you get what this 22,400. That is you'll be able to convert it for what from this dm cube, which is 22.4, towards this cm cube, which happens to be what 22,400. Are you seeing it now? So on that molar volume relationship, we have mole equal to what volume at STP divided by what by molar volume. Now please take note of what of this equation. They are very helpful when calculating what stoichiometry calculations. So please take note of what of this. So from here we'll also be talking about other related formulas under stoichiometry. We have mole equal to what concentration times volume. Concentration times volume. So this is under what? This is under equation under what? Under stoichiometry. So number of mole equals to what? Concentration times volume. It's either you write it like this or you write it like this. N also signifies what number of mole equal to what? C times V. This C is known as concentration, while this V is what? Is volume. And this N is what? Is the number of mole. Are you seeing it now? So please take note of what? Of this. So in case you are asked to find number of mole, when you are being given concentration and volume, this is the equation to what? To use. N equals to what? C times V. Where N is what? The number of mole. The unit is what? Is mole, which I've gave earlier on before. While this C here is what? The concentration. Whereby the unit of concentration is what? Mole per dm cube. So concentration is equal to what? Mole per dm cube. So this is what the unit mole per dm cube for concentration. While for volume, I gave it before. I gave the unit for volume before. The unit for volume can be in dm cube or cm cube. So volume equals to what? Dm cube or what? Or cm what? Cube. So please take note of what? Of this. So this is under better formula, under mole concept, under stoichiometry. So please take note of what? Of this formula. The next formula that we'll be talking about is N equals to what? PV over ROT. Now please take note that N, which is number of moles, is equal to what? PV over what? ROT. Where P, please take note that P is equal to what? Pressure. P is equal to what? Pressure. P is what? Pressure. Then V is what? Volume. So please take note of this, that V is volume. RO is what? Gas constant. Gas constant. So please take note of this, that RO is what? Gas constant. Whereby T is what? Temperature. So please take note of this. So N, which happens to be number of mole, is equal to what? PV divided by what? ROT. Where P is what? Pressure, V is volume, RO is gas constant, T is what? Temperature. So please take note of what? Of this. So this is under formula for what? Calculating what? Number of moles. Under what? Mole concept. So we should please take note of what? Of this. Now please take note that the unit of pressure, please take note that the unit of pressure is what? Atmosphere. ATM. This is the short form for what? For atmosphere. So please take note of what? Of this. Now please take note that for volume, the unit for volume is what? dm cube or cm cube. So please take note of what? Of this. Now this gas constant, please take note that gas constant has a what? Has a value. Now please take note that the value for gas constant is what? 0.082. So you should please take note of what? Of this. That the value for this gas constant is what? 0.082. So you should please take note of this. Now whereby temperature is given what? In Kelvin. So temperature is what? Is in Kelvin. So temperature in what? Kelvin. But if you are given degree Celsius, you convert it to what? To Kelvin by adding 273 by adding what? 273 to the temperature you are being given in degree Celsius, because temperature must be what? In Kelvin. But in case you are being given temperature in what? In degree Celsius, now you see the value for that temperature you are given degree Celsius, add 273 to that value, then you get your temperature in what? In Kelvin. So please take note of what? Of all these formulas. They are very helpful in calculating stoichiometric calculation involving what? More concepts. So you should please take note of what? Of all these formulas. Now, the last formula we're talking about in today's lesson is where we have number of mole. I said earlier on that you can tell that number of mole is still the same thing. Number of mole is equal to what? Mass divided by your molar mass times 1000 divided by what? By volume. So this is under formula again, under what? Mole concept. When you have number of mole equals to what? Mass divided by what? Your molar mass times 1000 over what? Over volume. So this is under formula again that we can use. Please take note of what? Of all these formulas. They are very helpful and very essential in what? In calculating what? Stoichiometric calculations. So please take note of what? Of all these formula. So with this, we have come to the end of what? Of today's lesson. Please, if you find this class very interesting and want to subscribe to my YouTube channel at Divine Online Chemistry Tutorial, please don't forget to like my video, and don't forget to share, and don't forget to also comment to my videos. Bye, and see you in my next post.